So to construct the line parallel to the given line that goes through a given point, first thing you're going to do is draw a line through the point that also goes through the line. Then you'll take your compass place it on the intersection of those two lines, stretch it out as far as you want, draw an arc, then without messing up your compass or without adjusting your compass, bring it down to the point and do the exact same arc. Then use your compass to measure the opening of that arc that you just drew. Then bring it down to the other arc and mark off that exact same distance. And then draw the line that goes through the point and that little X that you just created. And that line is parallel to the first line because those two angles are the exact same angle. We just copied the angle, so they are corresponding, which means the lines are parallel because corresponding angles are congruent. The important thing is, because there are more than just this one way of doing this construction. The important thing about constructions is that you cannot use a protractor. Protractors are not allowed for constructions. There's at least 3 ways that you can use your compass to do it. Make sure that you are not using a protractor. You can explain why vertical angles are congruent. We know they're congruent, but you can explain why they are congruent using rigid motion. You could rotate around the intersection right there. You could rotate about 180 degrees, and then angle 1 and angle 2 would match up. So rotation is one rigid motion that matches them up and explains why they are congruent. Also, if you fold it in half or draw the line of symmetry, it is symmetric. The 2 angles match up. You could reflect over that line. So reflection is also a rigid motion that shows that they are congruent. So given line A and line B are parallel, prove angle 1 and angle 5 are congruent. So if you go through, line A and B are parallel, then we've got angle 1. Angle 1 is congruent to angle 3. We know that those are congruent because the lines are parallel, and those 2 angles are corresponding angles. Then angle 3 and angle 5. Looking at the picture, angle 3 and angle 5, those are vertical angles, so we know that they are congruent. So then we can put those 2 together. Our final statement of every proof will always be the thing that we are trying to prove. Angle 1 is congruent to angle 5. And looking at what we've already said, we said angle 1 is congruent to 3 and angle 5 is congruent to angle 3. So we can combine those 2 with some substitution to get that angle 1 is congruent to angle 5. In the diagram, solve for x. So looking at the diagram, we can see that those are two angles that form a straight line. That's called a linear pair. And therefore, those two angles are supplementary. They will add to equal 180 degrees. So we've got an equation. We can now solve for x. So that's 15x 60 back to 60. 15x equals 120. And then divide by 15. X equals 8. So for this proof, we are given line X is parallel to line Y. So we know all the angle relationships that come with that. So we're going to start our proof by stating the given. So you always start. And then angle 8 is congruent to angle 6. So looking at those two angles, we know that that's true because those are corresponding. And we've got another statement, angle 6 and angle 5 are supplementary. So those two angles right there, that's a linear pair. That's how we know that they are supplementary. So now we know that 6 and 5 are supplementary and 8 and 6 are congruent. So we can substitute to get now that we're going to replace angle 6 with angle 8 because they are congruent. So we get angle 8 and angle 5. We're replacing the 6 with an 8 are supplementary. Which is also a thing that we are trying to prove, which needs to be our last statement. And we know that they are supplementary because all we did right there was substitution. We replace the 6 with an 8 because they are congruent. So explain why measure of angle CBA is 115 degrees. So first identify angle CBA. CBA. So that angle right there. So we know that this portion of it's 90 because it's marked right there. So therefore, angle CBA has to be larger than that because it's larger than the angle in the picture. Also, we know that angle EBG is 25, so that means that right here also is 25 degrees because those are vertical angles. And then the angle addition postulate just says that we can add the two pieces of this angle to get the whole larger angle. So 90 plus 25 equals 115 degrees. Explain why corresponding angles are always congruent when given parallel lines intersected by a transversal using rigid motion. So, draw some parallel lines intersected with a transversal. If we have that, then we know that these are corresponding angles. And it's pretty easy to see that if you wanted to talk about these with rigid motions, all it would take to get from one angle to the other is a small little translation. You just have to slide the bottom angle up to the top or the top angle down to the bottom, a little translation or a slide. So to identify if all these different lines from the given points are parallel, perpendicular, or neither, you need to know the slopes. So we'll get the slope of AB. Take y minus y, so that y coordinate minus first y coordinate over the x minus x. So that's 3 over 2. And then for our other segment, AD, we're going to take the coordinates from D and A, so negative 4 minus 0 over 5 minus negative 1 turns to addition, so that's negative 4 over 6, which you can reduce to negative 2/3. So 3 over 2, negative 2 over 3, those are opposite reciprocals, so they are perpendicular. We already know the slope of AB, so I'm just going to write that right here. We already used it. Now to find the slope of CD, we would take the D coordinates minus C coordinates. So negative 4 minus negative 1 over 5 minus 7. So that's negative 3 over negative 2, or positive 3/2. Those are the exact same slopes, so they are parallel. Now AC and BD. So for AC, we're going to do negative 1 minus 0. And 7 minus negative 1. So that's negative 1 over 8. For BD, take the D coordinate minus the B coordinate, so negative 4 minus 3 over 5 minus 1. That's negative 7 over 4. There's no relationship between those slopes, so they are neither parallel nor perpendicular. And to write the equation of line AB, we need the slope of AB, which we've used before. It's 3/2. And then we need either point. Let's take point A, which is negative 1, 0. And we will write the equation that has that slope passing through negative 1, 0. We do y minus the y coordinate equals m x minus the x coordinate minus negative turns to plus, and distribute, and we have our equation.